good day class, this is chemistry week 1 and our week 1 topic is hydrogen. So without wasting much of your time, let's go to the introduction of hydrogen. So hydrogen was first discovered in the year 1776 by Henry Cavendish. So it was discovered in the year 1776 AD by Henry Cavendish. So Henry Cavendish discovered hydrogen in the year 1776. We have 1776 AD. Then in the year 1786, Anthony Lavoisier named it hydrogen. So Anthony Lavoisier named it hydrogen in the year 1783. In the year 1783, Anthony Lavoisier named it hydrogen. So he named it hydrogen, and that name hydrogen means what? Water former. Alright, let's write that down. Let's write hydrogen here. So he named it what? Hydrogen, and it means what? Water former. It means what? Water former. So that is it for the introduction to what? Hydrogen. Now let's go to isotopes of hydrogen. Under the isotopes of hydrogen, because of some things I want to write on that here, let me write it and then I'll clean it. So as I'm writing, listen and also write. Under the isotopes of hydrogen, we have protium. Isotopes of hydrogen. Let me write the isotopes. We have protium. We have what? Deuterium. Then we have tritium. I would like to just write this list here. Protium, deuterium, and tritium. So now these are the isotopes of hydrogen. These are the isotopes of hydrogen. Protium, this is what? Original hydrogen. Ordinary hydrogen. These are ordinary hydrogen. It has no nucleus. It has no neutron, it has no neutron in its nucleus. It has no neutron in its nucleus. Then this is heavy hydrogen. It is heavy hydrogen, because it is 1.1 times denser than an original hydrogen. Ordinary hydrogen. Alright. Because of the matter, let me just go through this stuff again. This is protium. Protium is ordinary hydrogen. Its neutron. It has no neutron in its nucleus. It has no neutron in its nucleus. It has no neutron in its nucleus. Then deuterium. Deuterium is called what? Heavy hydrogen. It is 1.1 times denser than ordinary hydrogen. Then tritium, this last one, tritium is called radioactive hydrogen. Radioactive hydrogen. Radioactive hydrogen. So where are we entering? Let's get to the laboratory preparation of hydrogen. So now, we want to enter the laboratory preparation of hydrogen. So laboratory preparation of hydrogen, let me write lab here. Then under the laboratory preparation of hydrogen, we have what? We have the displacement of hydrogen from water. We have displacement of hydrogen from water. Now, displacement of H2 from water. Now, get this in your head. Elements like this, lithium, sodium, calcium, then potassium, these they react with cold water to liberate hydrogen. They react with cold water to liberate hydrogen. So write that down. Lithium, sodium, calcium, potassium, they react with cold water to liberate hydrogen. Then we have manganese. Then manganese displace hydrogen from boiling water. Now this one is cold water. That is the react. This one reacts with cold water. This one displace hydrogen from boiling water. Then let's go to other elements like lead, iron, zinc. All these ones, they what? They displace hydrogen from steam water. These ones, they displace hydrogen from steam water. They displace hydrogen from what? Steam water. Are you getting me? Now they displace hydrogen from steam water. They displace hydrogen from steam water. Now we are done. Okay, before we finish, there's another thing we should still know under the under laboratory preparation. Alright, another laboratory preparation. I don't want to waste much time. Under laboratory preparation, we also have what? Preparation by the action of what? Preparation by the action of metal in acid. Write that down. Preparation by the action of metal in acid. Are you getting me now? Metal in acid or from acid. Now, in that particular one, let's say we use Zn and HCl. Then when we put it here, we have Zn plus 2HCl. Balance it. We will have ZnCl plus what? H2. Alright. Now that is for laboratory preparation of hydrogen. Let's go to industrial preparation of hydrogen. Alright. Industrial preparation. Okay, let me just use it from this side. Industrial preparation of hydrogen. The two industrial preparation of hydrogen, we have what? Bosch process. We have Bosch process. Then we have electrolysis. Pen down. Now we have Bosch process and we have electrolysis. Bosch process, heavy amount of hydrogen is gotten through water gas. Under Bosch process, now in the Bosch process, the explanation you should get from this Bosch process is that heavy amount of hydrogen they are gotten from what? Water gas. Under Bosch process, right? Heavy amount of hydrogen are gotten from what? Water gas. Then electrolysis. That we have gotten to electrolysis. Under electrolysis, pen down. The purest form of hydrogen is gotten through electrolytic processes. I repeat, the purest form of hydrogen is gotten through electrolytic processes. Alright, let's get to enter uses of hydrogen. Now, under the uses of hydrogen, number one, hydrogen is used for filling balloons. Filling balloons. We have for filling balloons. We have production production or for producing what? Ammonia. NH3. We have for producing ammonia NH3. We have for making hydrogen bomb. Then we have hydrogenation. We have for hydrogenation. Alright, so I repeat, we have filling balloons, production of ammonia, making hydrogen bomb, then hydrogenation. So I want to explain, there's something under this hydrogenation I want to explain for you before we get to some keynotes you should know about hydrogen. Alright, so let's explain this hydrogenation for you. Now under hydrogenation, we have something called adding of oil. Now let's write hydrogenation here. Hydrogenation. Right, number one, we have what? Adding of oil. Then we have conversion of alkane and alkyne to alkanes. So we have adding of oil and conversion of alkane and alkyne to alkanes. Are you getting me? Yeah. Alright. So this is it for the uses of hydrogen. I've explained industrial preparation. I've explained laboratory preparation. I've explained isotopes. I've explained introduction. Now, pen down some notes that you can see as questions in your JAMB, WAEC, and all your external exams. Something that they will ask you. Now, note this down. Right? Note. Hydrogen is the most abundant element in the universe. Hydrogen is the most abundant element in the universe. We are here. Hydrogen is the most abundant element in the universe. Okay? 2. Hydrogen gives a pulp sound when giving off. Hydrogen gives a pulp sound when giving off. Another one is whenever hydrogen is being ignited in air, the only substance formed is water. Whenever hydrogen is being ignited in air, the only substance formed is water. Another one you should still also know is hydrogen is the most lightest element in the universe. So the most lightest element in the universe is what? Hydrogen. And other one that is still concerning this isotope, this deuterium and tritium that I taught you under isotopes, these two, they are only found in the sun. So deuterium and tritium are only found in the sun. So this is where we'll come to the end of our class for today. Get ready for chemistry week 2, and also for the physics, which I gave you, that we'll do scalar and vector quantities. Scalar and vector quantities will go for 2 weeks. So if I don't explain it in any video, know that by the end of 2 weeks I may explain it. Do you get me? So continue with your scalar and vector quantity. For hydrogen, we have trashed it. Your week 2 topic will come to you very soon. See you guys in our next class.